Hi, discussing the third numerical from the exercise for the chapter Gravitation. So let's start. Now the question says calculate the kinetic energy, the potential energy, total energy, and the binding energy of an artificial satellite whose mass is 2000 kilograms orbiting at a height of 3600 kilometers above the surface of our Earth. And then we have certain common values, such as the value for universal gravitational constant, which is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Then we have the value for the radius of the Earth, that is represented by symbol R, which is 6400 kilometers. And then the mass of the Earth, represented by symbol capital M, which is 6 into 10 raised to 24 kilograms. And using all these quantities, as I said, we are required to calculate the four energies, that is kinetic, potential, total, and binding energy for the satellite. So let us quickly write all the given data that's been given to us. The first quantity that's given to us is the mass of the satellite. We represent it using the symbol small m. This mass is said to be 2000 kilograms. So it becomes 2 into 10 raised to 3 kg. Just a simple way of representing 2000 as 2 into 10 raised to 3, easier for calculation. The second quantity जो हमें question में दिया है, that is the height at which our satellite is orbiting. So we represent that height using the letter small h, and this height is said to be 3600 kilometers, which becomes 3.6 into 10 raised to 6 meters. The third quantity that's known to us is the mass of the Earth. We represent it using the capital M, and this is 6 into 10 raised to 24 kilograms as well. And the fourth quantity जो दिया है, that is the radius of the Earth, which is 6400 kilometers, which in terms of meters is 6.4 into 10 raised to 6 meters, as 1000 meters is 1 kilometer. And the fifth quantity, whose value we already know, that is the value of universal gravitational constant, that is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now, using these five quantities, we are required to find a bunch of energies. So सबसे पहले हमें ढूंढना है kinetic energy of our satellite. उसके बाद हमें ढूंढना है potential energy of our satellite, represented by symbol PE. Then we are required to calculate the total energy of our satellite at height h. And then finally हमें ढूंढना है the binding energy for our satellite, and we represent binding energy using the symbol BE. Now let's try to understand what sort of formulas we can use to calculate all these energies. सबसे पहले we calculate the kinetic energy. So kinetic energy का formula is given to us is G into mass of the Earth into the mass of the satellite divided by 2 into R plus H, where R plus H is the total distance between the artificial satellite and the center of the Earth. Okay, so this is the formula with which we can calculate the kinetic energy of an orbiting satellite. The second formula is to calculate the potential energy, and potential energy ka formula is minus gm, that is the mass of the Earth, into small m, mass of the satellite, divided by the distance between the satellite and the center of the Earth, that is r plus h. And if we were to compare both these equations, so this term and this term, so we can say that potential energy and kinetic energy ka relation is potential energy is equal to minus into twice the amount of kinetic energy. So that is the relationship between potential energy and kinetic energy of an orbiting satellite. इसके बाद the third energy जो हमें ढूंढना है, that is the total energy, and it is pretty easy because total energy for any satellite is simply the addition of its kinetic energy and the potential energy. So this is the definition for total mechanical energy. And the fourth quantity जो हमें ढूंढनी है, that is the binding energy, and by definition binding energy is the minus or the opposite of total energy of the satellite orbiting at the height h. So these are all the formulas, and हमें जो है इन formulas के सारे values given है already. So all we have to do is substitute the values and do the calculation. So हमारे calculations में सबसे पहले हम calculate करेंगे the kinetic energy for our satellite. So from formula 1, let's find our kinetic energy. So kinetic energy, Ke, is equal to, so if we substitute the given values in the formula of kinetic energy, we get the expression as G ka value is 6.67 into 10 raised to minus 11 into the mass of the earth, that is 6 into 10 raised to 24 kilograms, into the mass of the object, that is 2 into 10 raised to 3 kilograms, and the whole thing divided by factor of 2 into the distance between the satellite and the earth, so that is the radius of the earth, that is 6.4 into 10 raised to 6, plus the height at which the satellite is orbiting, that is 3.6 into 10 raised to 6 meters, and we close this bracket. And the first thing हम क्या कर सकते हैं कि we can get rid of the 2 in the denominator and 2 in the numerator, and we can solve all the 10 raised to जो भी हमारे terms है. So I keep 6.67 into 6 as it is, and 10 raised to minus 11 into 10 raised to 24 into 10 raised to 3 gives us 10 raised to 16 by the laws of indices, and 6.4 into 10 raised to 6 plus 3.6 into 10 raised to 6 gives us 10 into 10 raised to 6, which can be written as 6.67 into 6 into 10 raised to 16. The whole thing divided by 10 into 10 raised to 6 is 10 raised to 7. And then if we divide 10 raised to 16 by 10 raised to 7, we get the term as 6.67 into 6 into 10 raised to 9, because 10 raised to 16 divided by 10 raised to 7 gives us 10 raised to 9. And if we solve this further, we get the value for our kinetic energy of our satellite as 40.02 into 10 raised to 9 joules, which is the unit to measure energy. And I call this my equation number 1. So हमने जो है हमारा न्यूमेरिकल का फर्स्ट टास्क कंप्लीट कर दिया है, that is to calculate kinetic energy. Now let's quickly calculate all the other energy. So from formula 2, I can pretty easily calculate the potential energy, as by definition, potential energy for an orbiting satellite is equal to minus into 2 times the kinetic energy of the satellite. And हमने जो है kinetic energy of the satellite already calculate की है, so it would be minus 2 into 40.02 into 10 raised to 9. That is the value of kinetic energy which we calculated in our equation number 1. So this gives us the potential energy for our orbiting satellite as minus 80.04 into 10 raised to 9 joules. Joules, that is the symbol for that is the unit for energy. So with this, let me mark this equation as equation number 2, and हमने हमारे numerical की second energy भी calculate कर ली है. Now let's calculate the other two energies as well. तो सबसे पहले first we'll write from formula number 3, let's calculate the total energy. So from formula 3, I can say total energy for an orbiting satellite is the summation of its kinetic energy plus its potential energy, and we already know the value. Kinetic energy of the satellite is 40.02 into 10 raised to 9, and the potential energy is minus 80.04 into 10 raised to 9, and we got these values from our equations 1 and 2. And if we were to perform this addition, total energy of the satellite comes out to be minus 40.02 into 10 raised to 9 joules. So this is the third energy जो हमें पूछा था in the numerical, and I'll mark this equation as equation number 3. And let us now quickly calculate the fourth and the final energy. So from formula number 4, we can calculate the binding energy for the satellite. So binding energy represented by symbol BE is equal to minus of the total energy, and total energy जो है हमने अभी अभी calculate किया है, that is minus of 40.02 into 10 raised to 9. So the value of total energy comes from equation 3. So equation number 3. So इसी के साथ हमारी final energy, that is the binding energy of the satellite, comes out to be positive 40.02 into 10 raised to 9 joules. Joules, that is the unit for measuring energy. And this was our fourth and final energy जो हमें ढूंढना था for this particular numerical. So we have successfully calculated the kinetic energy, the potential energy, the total energy, and the binding energy for our orbiting satellite. The PDF of the solution is available in the description. So make sure you check that out. Thank you.